In this part of the lecture, we are going to introduce two additional process mining capabilities, and those are performance mining and variant analysis. Let's begin with performance mining. So performance mining takes as its input an event log and sometimes also a set of business rules. A potential result of performance mining is an enhanced process model which gives us additional information that we didn't see with automated process discovery. So let's look at it in a bit more detail. Process mining tools typically support performance mining in three ways. 1. Performance-enhanced process maps, which I will discuss in the following slide in a bit more detail. 2. Dashboards, which we saw already in the previous lecture. And finally, log animation, which we haven't seen thus far yet. However, when it comes to performance-enhanced process maps, then few things to point out here. We still have activity labels. However, in a performance map, it's going to be shown with the activity duration. Also, we have the arcs between the activities, so that directly follows relations. But in this case, those are going to be presented together with the waiting times. That is, the time between finishing the first activity and starting the next activity. Also here we can see easily bottleneck nodes. Nodes where all incoming arcs are slow. That means that there is some kind of a queue that is forming in front of that activity. So let's do a small demo and look at how those techniques actually look like in Apromore. So here I have the same event log that we looked at in the previous parts of the lecture. Again, treatment of sepsis cases. I have it opened without any filters and with the default abstraction settings. If we want to look at the performance of this process, then one way we can do it very easily is by just going here, clicking on the duration part, and now the overlay of the process is going to change. Here we are going to see, for example, what is the average difference or the average waiting time between ER registration and ER triage. In addition to average times, we can also modify the overlay by showing us, for example, the maximum time, which is 1.45 hours. Or we can see, for example, the minimum time, which is 41 seconds. Or we can also see total time, which tells us kinda overall how much time is spent waiting here in the total time frame of our process. Now, while I mentioned already the overlays here, I will come back to the frequency one for a brief moment, because here we can also change the different overlay types or the different numbers that are going to be displayed. For example, I could see the relative case frequency, I could see the minimum case frequency, or the maximum case frequency. Now, one additional thing that I promised to mention is looking at specific process instances. And this can be done very easily by just clicking on this number here. This will give us a case inspector view. And right here we can just click on a specific case that we want to see, and we can instantly see how it looks like. And also notice that this view, by default, it already drops into the performance view where we have times. The reason is that the frequencies of activities don't really make sense to look at when you are looking at one case in isolation. An additional thing to look at here is that the activity durations, well, first of all, we can see all the attributes related to this ER registration event, but also we can see that the activity duration is marked as instant. Now, this is because we have imported an event log, or we are looking at an event log where we have only one timestamp per activity or per event. To show you a better way, I will open up a different event log that I used in the previous part of this lecture as well, which is the device repair event log. If I open it in Process Discoverer and I go to the duration overlay, then here we can also see that the durations of the activities are now shown. Some of them are still instant, by the way, but some of them where actual work is being done. For those activities, we have actual durations, and we can figure out which of the activities take the most time in our process. Here, I will also come back to the abstraction settings, because we can abstract the process map based on average duration of both the events and also the waiting times of the process. So here, for example, this would be the full process map, and now I am keeping only the fastest paths in the process. The next part on the slides was performance dashboards. However, since we have covered them already in the previous lecture, I will not be demoing them here. However, what I will show you is log simulation. So this we can start easily in the process discovery view. We just click on the button animate. It will basically give us a timeline, and here we can start running the process. I can actually go to a more interesting part of the process, and what we can actually see here is how the process instances are actually moving through the process itself. Now this view, it can in some cases be a very useful view in order to visualize the bottlenecks that are forming in my process. Additionally, it can actually be viewed, or the simulation can be run using multiple logs at the same time, and this leads us to variant analysis, which I will be covering next. So as already hinted at multiple times, there is one piece missing from this picture, and that is variant analysis. Now variant analysis is going to take an event log, and actually at least 2 event logs of the same process, and then is used to get an understanding of the differences between those 2 event logs. So the purpose of variant analysis is to find differences in performance and control flow between multiple variants of a process. A process variant, in this case, is a subset of the executions of a process corresponding to a given product, customer, and so on. For example, we could take cases that are relatively simple in terms of control flow, and we could compare them to cases that are more complicated. In process mining tools, such as Apromore, variant analysis can be approached as follows. First, we use filtering to slice the event log into multiple logs, 1 per variant. And then we are going to compare the multiple logs using side-by-side comparison of process maps or process models, or a comparative multi-log dashboard, or multi-log animation. And actually variant analysis can be a very useful tool in multiple cases. For example, if we have a process, the same process that is going to be fulfilled in Estonia, Latvia, and Lithuania, and we figure out in Latvia, for some reason, the process is performing much better than in Lithuania and in Estonia. Then we could take that event log, split it into 3 parts per country, and figure out why one country is performing much better than other countries. So let's do a small demo and look at how variant analysis would look like in Apromore. Now to demonstrate variant analysis in Apromore, I will be using the same device repair event log that we used previously. I have already stopped the animation, I have gone back to the frequency overlay, and I have also reset the abstraction settings. So the first thing I'm going to do, I am going to filter this event log. I will do it based on activities. I'm going to keep only the cases where repair simple occurs. I will click OK, OK again, and the log is instantly filtered. I will save the filtered log as a separate event log file. Here I will just add the prefix or suffix simple. I will click OK, and it will say that a new log named this has been saved in my home folder. Now I will repeat the same process, but this time I will just modify the existing filter, and instead of repair simple, I will just change it to repair complex. I will click OK, OK again, and now I have a different subset of process instances and I will take those process instances and save them as a different event log. And I will of course name it as complex. And again, it tells me that the device repair complex event log has been saved in the home folder. Now the obvious thing that I can do, I can go back to my workspace, and here I can just double click device repair simple, open it up in the process discovery view, and double click device repair complex. Obviously, if I want to look at them side by side, then the easy way to do it is just to move this into a separate window, move it to the one side, and on the other side, just put the simple one. Now to make things a bit easier, I will change the layout from top to bottom, and here as well, and now I can see the process maps side by side and compare them visually. Another way of doing it is via performance dashboards. If in the previous demo I skipped them, then in this one I will not. The reason is because now the performance dashboard is going to look a bit different. I will select both of the event logs by holding Ctrl. I will right click on the event log and I will click Launch Dashboard. Now this will give us a slightly different dashboard than what we saw in the previous lecture. Here we can see side by side both of the event logs that we are currently looking at. We can see activity instances over time for both slices of the process that we defined before. We can also see the work in progress in exactly the same way, or case variants, case duration, and so forth. And this is a very useful view if we want to compare different performance metrics of different slices of the same process. And the third and final thing that I'm going to briefly show is log animation. For demonstrating the log animation, we will use the same sublogs or slices that we had before, but in addition, we are going to select a model as well. And once we have a model selected as well, we are going to go to Analyze and click on Animate Logs. Now this is going to give us a view where we have the model as we had in the conformance checking, and here we can start an animation where the process instances of both event log slices are going to be animated simultaneously and in sync. So both of them are going to be synchronized to the same time, and we can see the bottlenecks that are going to appear in one process slice versus the other process slice. And now, to summarize this lecture, the bulk of process mining techniques can be divided into 4 capabilities. We have automated process discovery, we have conformance checking, we have variant analysis, and we have performance mining. And each of those can be used in order to analyze the process in a different way. With regards to the structure of the course, the next week we are going to focus on the automated discovery approach and the different questions that a business process analyst or the process owner might have that can be answered using the automated discovery techniques. So thank you all for listening, and I hope that it was very interesting to you, and I hope to see you next time as well.